Next, I want to talk about an application of rational expressions, which are the difference quotients of a function. So a difference quotient of a function can be expressed in this way, right here, this quotient. So it'll be f of the expression x plus h minus f of x divided by h. So for example, let's consider this function, f of x equals negative 3x, and let's see if we can compute its difference quotient. So just writing out f of x plus h minus f of x over h. Okay, we can try to compute this or simplify it as much as possible. So the only trick to this really is this first part, like what is f of x plus h? Well, in order to compute that, all you do is you just replace anywhere that you see an x in the function with an x plus h. It's as if you're plugging in, instead of x, you're plugging in this x plus h, which we kind of saw in the section on the lecture that we talked about composition of functions. This is effectively a composition. So what we're going to do is we're going to replace this x here with this x plus h, because if I were to plug in this value, that's what we would get there. And then minus f of x is exactly this right here, the negative 3x. Okay, and finally this is still divided by h. Okay, so now you want to simplify this using similar techniques that we just did above. So the denominator can't really do anything at the moment because I don't have a factor of h up top. But what happens if we simplify this? So if you kind of expand what we have up top, so distributing this negative 3, we would have negative 3x, and then negative 3 times h would be negative 3h, and then this will be negative makes this positive 3x, all divided by h. And then now notice the 3x's are going to cancel here because I have negative 3x and positive 3x. So these two terms are going to go away, and you're left with just the negative 3h over h. And now you actually can do some reduction because I have an h in both the numerator and denominator as a factor. So I'm actually left with negative 3. So the difference quotient for this particular function actually simplifies to just negative 3. Well, what happens if we look at some more complicated functions, such as f of x equals 3x squared? Well, it starts out exactly the same. You're going to still compute what the difference quotient expression is. So f of x plus h minus f of x divided by h. Okay, so now my function is 3 times x squared. So if I'm trying to compute what is f of x plus h of this expression, instead of 3x squared, I'm going to have 3 of x plus h squared. Right? You see that this is your input, so you're basically replacing the input exactly here. Just as if you were going to compute, say, f of 2, right? You would replace x with that 2, and you would compute this, right? You're doing the exact same thing, except I'm using x plus h instead. Okay, so then minus f of x, which is just 3x squared, divided by h. And again, in order to simplify this, you're going to have to expand this. So we'll FOIL this out, right? So 3x plus h, x plus h, and minus 3x squared. Okay. And then let's FOIL this expression out. So we have 3 times x squared, and then plus hx will be plus 2 xh, and then plus h squared. And then still, we're kind of carrying this minus 3x squared along. Still this divided by h here. And now I can distribute in this 3. So we have 3x squared plus 3 times this will be 6, right? 6xh plus 3h squared minus 3x squared in the numerator. And still divided by this h. And now notice I have a 3x squared and a minus 3x squared, so those actually will cancel. That's not always going to happen, right? Sometimes you'll combine terms and you won't get full cancellation, but in this case, this ended up being quite nice. Let's see here. Now, up top, you're left with something that actually has an h factor in both terms here. So this, I can actually factor an h out of these two terms, and I would be left with 6x with the first one, and then plus 3h with the second one. And now notice I can actually reduce the h, and so we're actually left with 6x plus 3h. Now notice it is fine to actually have a final answer that has x's and h's in it, because the original definition for the difference quotient has those two variables in them, x and h. So it might seem a little bit strange at first, but you can have both of these variables in the final answer. And if any of you go on to some more advanced math courses, you'll see this difference quotient come up again in other applications. And so let's try to do the same thing for more complicated functions, such as a general quadratic like this. Right? The second example here is a quadratic, but this one's a little bit more complicated. So the procedure is still exactly the same. So you're going to start with f of x plus h minus f of x divided by h. And now, when I go to plug in this x plus h into my function, do you notice that there's going to be two places I have to replace the x? Okay, so this will actually be x plus h squared plus 4 times x plus h minus 7. Okay, so again, when I'm computing f of x plus h, wherever I see an x, I'm going to have to replace it with my input. My input in this case happens to be this x plus h, so we're going to have to replace that in these two spots, right? Here where it's squared and here where it's multiplied by 4. And then subtracting the entire function, let's put that in parentheses so we don't make a mistake. So I'm going to subtract x squared plus 4x minus 7. All right, let me add a little line here so we don't combine stuff. And then this is all divided by h. Okay, so next step, let's FOIL this out and we'll distribute some of these terms. Okay, so this is x plus h. Well, at least let's just write it out. Okay, x plus h times x plus h, and then we can distribute this 4. So this will be 4x plus h. Oh, sorry, 4h minus 7, and then minus this negative is going to get distributed. So this will be minus x squared minus 4x plus 7. Okay, all divided by h. Okay, and already we actually get some cancellation, which we can take care of right now, right? This 4x and this minus 4x, this minus 7 and this plus 7. And in the next step, let's FOIL out this term here. So we'll have x squared plus 2xh plus h squared. And then we still have this plus 4h. And then we have minus x squared all divided by h. Okay, and then now the x squared and this minus x squared cancel. And we can actually combine, no, we're going to leave this alone, right? None of these three terms up here are going to combine in any nice way, because this has an h term, but it also has x terms, so it's not going, or an x factor, so it's not going to combine with this, and this has an h squared. But one thing that is common is every single one of those terms have an h in it, so we can actually factor that out. So we actually have h times this 2x, right, this term, and then if I factor an h out of the h squared, I'm left with one of these h's, and then if I factor an h out of 4h, I'm left with a 4, and I still have the denominator h. And now look that I've factored this h out, I can actually reduce it, and so my final answer actually is 2x plus h plus 4.